Welcome to the Explainer. If you're a developer, an engineering manager, or really anyone working closely with a software team, you have definitely heard someone sigh and say, man, our codebase is just a complete mess. It's literally a universal frustration. But today, we're going to flip the script on how you look at that mess. We're going to break down exactly why systems get so tangled up in the first place, and more importantly, we're equipping you with a real deal, concrete toolkit to actually fix it.
Here's our agenda for today's Explainer. First, we'll pinpoint the root of the problem, the tightly coupled codebase. Then we'll crack open our architectural toolkit to look at three very distinct, very powerful solutions: hexagonal architecture, CQRS, and vertical slice architecture. Finally, we'll wrap it all up by figuring out how to choose the exact right fit for your team. Let's jump in.
So part one, the tightly coupled codebase. What exactly is this mess? Well, before we can fix anything, we gotta define what developers are actually complaining about.
Listen to this. When engineers say their codebase is a mess, they almost never mean the code itself is actually broken or failing to run. Seriously, most software projects start off as a standard layered N-tier monolith, which is super easy to build. But as things grow, well, something kind of insidious happens. The real villain of our explainer today isn't bad code. It's what happens to the boundaries of that code over time.
That villain actually has a name, and it's called tight coupling. When developers vent about spaghetti code, this is really what they're talking about. Tight coupling is when a tiny, completely innocent change, like say tweaking one single database column or updating a payment gateway, suddenly forces you to rewrite your entire core business logic. It's a total domino effect. The boundaries have completely blurred, and everything is just hopelessly tangled together.
To fix this, we've got to make a pretty massive mindset shift. We need to stop obsessing over where our code lives, the physical folders in the workspace, and start focusing on how dependencies flow. We need to look at our architectural boundaries. And once we stop thinking about folders and start thinking about flow, we are ready for the first tool in our kit.
Which brings us to Section 2, Hexagonal Architecture, or as it's often called, ports and adapters. This pattern is built specifically to protect the absolute most valuable part of your entire system.
Let's contrast the old way with the new way. In a classic MVC setup, model, view, controller, the database is basically treated as the center of the universe, right? Your business logic directly imports those database models, so if you ever decide to switch from Postgres to MongoDB, you're pretty much rewriting all your core workflows. Hexagonal architecture takes that concept and turns it entirely inside out. In this setup, your core domain logic sits right at the center, and it has absolutely zero dependencies. None. It doesn't know a thing about your database, your web frameworks, or any external APIs. Okay, so how do we actually build it? It's surprisingly physical when you think about it. Step 1, you define a port. This is just an interface or abstract class that lives totally inside your core domain. Step 2, you build out your core workflow so it only depends on that specific port. And step 3, you connect an adapter. This is your actual concrete implementation, like a DynamoDB table or a REST API, and it sits completely on the outside. Basically, external systems just plug right into the core domain, exactly like plugging a lamp into a wall outlet.
Let's ground this with a real-world example. Imagine you've got a fintech app handling payments. The wrong way to build this, the tightly coupled way, is having your core billing service called the Stripe SDK directly. If you ever want to switch providers to get better fees, boom, your code breaks. But the architected way, your core domain just defines a payment gateway port. Your system only cares that some payment gateway exists out there. Then, your Stripe-specific code lives in a Stripe payment adapter far away from the core. The beauty of this is that you can swap it out for a PayPal adapter or Adyen or even a fake mock adapter for testing offline, and you do it without touching a single line of your core business logic. It's a real game changer.
Moving right along to Section 3, CQRS, reads versus writes. Here we're introducing a pattern built specifically to absolutely crush massive performance and scaling bottlenecks.
CQRS stands for Command Query Responsibility Segregation. It's a mouthful, but it simply means splitting your codebase into two totally distinct pathways, one for reading data and one for writing data. See, in most legacy codebases, the exact same data model tries to do both. You end up forcing lightning-fast dashboard reads and highly secure, complex data writes through the exact same bottleneck. And as your application scales, that creates a ton of friction.
CQRS fixes this by forcing a clear divergence. The write path, which we call commands, is hyper-optimized for modifying the system. That's where all your heavy business rules and transactional safety checks live.
On the flip side, the read path, the queries, is optimized purely for high-speed retrieval. Actually, the read path can completely bypass your complex domain models and just grab flat data directly from a fast cache like Elasticsearch or Redis.
To really picture this, think about an Amazon flash sale. You've got millions of people frantically refreshing the product page to check stock. Those are your queries. At the exact same time, thousands of people are furiously clicking Buy Now. Those are your commands. If you forced both of those actions through the exact same data model, running massive SQL joins every time the page loaded, your database would instantly lock up and crash the whole purchase path. But CQRS saves the day here. By splitting them, you can infinitely scale up your read servers to handle millions of views safely, while keeping your write servers secure to process the actual orders.
Now for Section 4, Vertical Slice Architecture, where we organize by features. This pattern is all about dramatically speeding up your developers and lowering their cognitive load. If you've ever watched a coding tutorial, you were probably taught technical layering. You make one folder for controllers, one for services, and one for models. But the frustrating reality is that to build just one simple feature, like, say, a password reset, an engineer has to jump between 5 different folders and modify files spread across the whole workspace. It's exhausting, and it guarantees constant merge conflicts with your teammates. Vertical slicing throws those technical layers completely in the trash. Instead, you organize your code strictly by feature or business capability. Everything needed for one specific feature lives together in one single encapsulated folder.
Take a modern platform like Medium, for example. If you organize your code into vertical slices and you need to update how an invoice is generated, you just open the Create Invoice folder. Your routing, business rules, and database queries for that feature are all sitting right there. And the absolute best part? Because you aren't messing with global files, there is zero risk of accidentally breaking the user profile system because those files live in a completely different slice. It just makes working on a fast-growing team incredibly smooth.
Which brings us to our final section, Section 5, Choosing Your Architecture. We've just gone over 3 incredible tools, but how do you actually know which one to pull out of the box? Well, I'm going to give you the cheat sheet right now.
Let's walk through this definitive matrix. Remember, these aren't competing ideas. They're specific tools for specific scaling problems. You're going to want to grab hexagonal architecture when your main goal is isolating your valuable business logic from unstable third-party APIs. It's absolutely perfect if you're deploying across multiple clouds or doing heavy automated testing without a live database. You'll want CQRS when you need to separate complex data modifications from super-fast data retrieval. It is the gold standard for high-traffic systems like streaming platforms, where reads vastly outnumber writes. And finally, vertical slice architecture is your go-to for minimizing code coupling by organizing around business capabilities. If you've got a fast-growing, agile team that needs to ship features rapidly without merge conflicts slowing them down, this is the one for sure. So, as we wrap up this explainer, I have a question to leave you with. Which of these patterns is going to finally fix your tangled codebase? More importantly, are you going to keep letting tight coupling push back your deadlines, or are you going to start drawing some intentional boundaries today? I challenge you to take this toolkit back to your desk and start untangling things. Thanks for joining me on The Explainer, and keep building great things.